Hello, everyone. Welcome to our online seminar. Thank you for giving your time in your busy schedule. Let me introduce myself first. My name is Wakako Matsuo. I'm from sales department, and I'm in charge of Russian and Ukraine market. Today, our director, Hirofumi Matsuo, is also joining us.
Здравствуйте. I'm Matsuo. Thank you for your coming to the fruitful workshop. This workshop, we will make a presentation on our technology and our product from the specialist. And I believe that this workshop will be helpful for your activity every day. And so I hope you understand the product deeply, and if you would like to have some interest in our product, please contact us. Thank you.
Thank you. And today's our presenter is Dr. Sofia Soto Rodriguez. She is experienced embryologist and was trained in vitrification directly by Dr. Kawayama. In 2014, she became an official trainer of the Cryotec method in workshops. She is currently part of the Ripple Life Technical Support Team, official trainer and lecturer of Cryotec, as well as senior scientist at Ripple Life. So, Sophie, can you start your presentation, please?
Sure. Hello, everyone. First of all, I'm going to share my screen so everyone can see my slides. Okay. So today I'm going to show you a series of frequent questions from clients. And the purpose of this seminar is to understand what's going on during our vitrification. So it's very important to understand what's going on. So the deeper you understand what's going on inside the cell during the procedure, you're gonna have better performance during your protocol, and this will help us have better results, increase our results. Okay, so today we're focusing only on vitrification. So I'm going to show some questions about vitrification to explain the answers. Maybe they will be a little bit technical, but it's with the purpose to understand. And at the end, if you have more questions, I will try to answer them the best possible. Okay, so let's start. First of all, after oocyte retrieval, how many hours should the oocyte be cultured before freezing? So we are going to follow our normal timeline. Usually we have the HCG trigger, and after 36 hours, we have the egg retrieval, and we usually culture about 2 hours after the egg retrieval. This is because the oocytes are not fully mature. And then we are going to do the normal denuding, and after denuding, we can do the vitrification, warming, and etc. So it is shown that after 40 hours of the HCG trigger, the oocytes start to lose their fertility ability. So including the vitrification and warming in our timeline, as long as it is maximum 40 hours from HCG administration to ICSI, it's okay. We need to avoid unnecessarily long culture because this may decrease the fertilization rate. So after denuding, we don't need to wait. So just in between the retrieval and ICSI, we wait 2 hours culture after retrieval, then we denude, immediate vitrification, warming, 2 hours culture post warming, and then ICSI. I will go deeper a little bit in each step. So how long should oocytes be cultured from denuding to freezing? So it is possible to freeze them immediately after denuding. This is the importance from denuding, from retrieval to denuding, is that the oocytes are not fully mature. When we take out the oocytes from the follicle, we are stopping some maturation cascade, and the signaling from the ovary to the oocyte is not finished for maturation, and this can cause that the oocytes that we take out from the patient have asynchronous maturation. Maybe if immediately after retrieval we denude them, maybe we will see a mature nucleus, so we can see a polar body, but the cytoplasm is not ready. This is why we're going to leave 2 hours culture after retrieval. And after these 2 hours, the oocyte is fully mature, and now we can remove the cumulus cells. And after this, the oocyte is ready for everything else. So after removing the cumulus cells, we don't need to wait any longer for vitrification. So the oocyte does not need the cumulus cells anymore, and we can go to vitrification because we can vitrify any step of oocytes and embryos. So since we don't need the cumulus cells here, we remove the cumulus cells and we can go immediately to freezing. Okay, for how many hours should oocytes be cultured after thawing from ICSI? Here we need to wait at least 2 hours. This is because the membrane and the spindle need this time to reassemble. It has been shown in some studies that the polar body move away from the meiotic spindle. Usually, this is the polar body. Usually the meiotic spindle is here, just in front of the polar body. And after vitrification, you can see it can be moved. This is fresh oocyte. In this one, the spindle is opposite. This is immediately after vitrification. This is without letting some time for recovery after warming. You can see, well, you cannot see the meiotic spindle because the meiotic spindle is not reassembled here. So all the DNA is spread in the cytoplasm and is not good enough for fertilization. So after a time in culture, you can see the spindle again reassembles, but here you can see that the spindle is not in the original place. So the spindle sometimes move. So in these cases, it could be possible that after warming, the fertilization rate can decrease. But attention, this is not because of vitrification or the protocol itself. This is because the condensation of the meiotic spindle. To avoid this problem, we can use a polarized microscope like this one, where you can see where is the meiotic spindle, and then put the meiotic spindle in a space where it will not affect when we put the needle inside for ICSI. So important, wait at least 2 hours so we can see the spindle, and we try to observe the spindle instead of the polar body. We don't need to pay attention to the polar body. If you have polarized microscope, pay attention to the spindle to increase our fertilization rate after oocyte freezing. How many oocytes or embryos can be frozen per plate? Well, this explanation is mainly for oocytes because I think you will not warm 15 embryos from the same patients. So in order to freeze oocytes under the same conditions in the same plate, you can put 15 oocytes at the same time to freeze very fast without having to restart the timer every time. So in this case, we're going to freeze 15 oocytes. We put 15 oocytes in ES. We start the timer And the first 3 to recover 100%, we're going to take them and go to the next steps to make a cryotec, and we're going to repeat it 5 times using 3 oocytes each time. But pay attention, every time you freeze, every time you use these oocytes, you perform again the procedure. We need to use a different area from the well. So first time you take the oocytes and then wash here and the top. Next time you can wash here and the bottom. Next time you can wash here. This is because we have a lot of area, a lot of surface in the VS wells, but since we're bringing some ES to VS, the surface is getting dirty. So it's better to do it every time in a different area. First at the top, then at the bottom, or whatever you want. Just make sure every time you perform the VS washing steps, go in a different area so the oocytes can have a good exchange of solutions to make sure there's no more ES inside of the oocyte. Okay, can immature eggs oocytes be frozen? Yes. All immature oocytes can be frozen using exactly the same procedure, but since they are a little more susceptible to osmotic pressure, we need to be extra careful. However, when we freeze immature eggs, make sure we leave a little bit of cumulus cells because we need the cumulus cells for future maturation. So this goes to the next questions. Can oocytes with cumulus cells be frozen? Yes, they can be frozen, and we recommend to leave about 50% of the cumulus cells. First of all, because removing 50% gives us a better visualization of the oocyte, what's happening, how they're shrinking, how are they recovering. And also this space gives us the chance for a free flow of water and media inside and outside the oocytes. And another important thing is that the remaining cumulus cells are going to help the oocyte get mature in future maturation in IVM. So to accomplish this kind of denuding, 50% denuding, we're going to use a pipette the size of the denuding pipette. And slowly and carefully, we're going to aspirate the oocyte with the whole cumulus cells. This one, the cumulus cells was like this. Remember that in GVs, the cumulus cells are very compact. So the cumulus cells, what's here, we aspirate the oocyte slowly, and with the same pipette, the cumulus cells are gonna be scratched and removed. Only one time in and out, and you can have this kind of denuding, 50% denuding on your immature oocyte. You can vitrify, you can clearly see how the water comes out, and it gets recovered with the solutions, and it's enough for water and cryoprotectant exchange and enough cumulus cells for future maturation. Can morula-stage embryos be frozen? Yes, also everything can be frozen with Cryotec method. But in morula, since we cannot see cells individually, we have to wait for the maximum time in EX. But there are two kinds of morulas. We need to observe if it's a compact morula or an early and expanding morula after compactation. If the morula does not have a cavity, like this one, the maximum recovery time is 12 minutes. This is because this morula is a lot of small cells, and these small cells do not need too much time to take out the water and to introduce the cryoprotectant. So this kind of morula needs only 12 minutes. But this late morula that already is start to create a cavity, this cavity is already full of water, full of fluid. So this many fluid will take longer time to come out and to be replaced by the medium. So this kind of morula will need 15 minutes maximum, both to the maximum. This will go to 15 minutes to wait for the water to come out of the cavity, come out of all the cells, and the medium with cryoprotectant come back in. This is because we cannot clearly see the shrinking and the recovery. So pay attention to the stage of the morula. If it's compact morula with no cavity, 12 minutes. If it's already making a cavity, 15 minutes, and then go normally to the VS steps. Now go for expanded blastocysts. How should expanded blastocysts be frozen? This also goes for fully hatched blastocysts. We can also vitrify fully hatched blastocysts. So when we have blastocysts bigger than 220 micrometers diameter, we are going to make a hypertonic solution. This hypertonic solution, we're going to prepare it with 2 solutions of the warming kit, DS solution and washing solution. We're going to mix 2 times of the DS, we can remember by the number on the cap, and 3 times washing solution, sorry. You can also remember it here. For example, we put 20 microliters of DS and 30 microliters of washing solution. We mix these solutions and we're going to create a droplet of 50 microliters. This solution is going to be an osmolarity between the culture medium and the ES. So remember, ES is 2,500 osmol. So we're going to go somewhere in between. So now with this middle osmolarity, we will put our expanded blastocysts here. We're going to wait a few minutes, 1 minute, 2 minutes, until we see it shrinking enough to about 220 micrometers. And then we're going to start our normal protocol. So here, if the embryo, if the blastocyst takes longer than 2 minutes, don't worry, just keep it there a little bit longer. If it takes 5 minutes, it's okay. It's totally safe because these solutions do not have cryoprotectants. So it's safe that the blastocyst is here. It's only a little bit higher osmolarity, so the water comes out a little bit. So we need to mix both solutions. This one, remember, it has the same osmolality as the culture medium, and this one has a higher osmolarity. So if we put directly into here, the water will come out very fast, and it's no use. So by mixing this one, DS, with washing solution with the same osmolarity as the culture medium, we're going to create the medium osmolarity, okay? After we have the shrinking, we go for the normal protocol. So this is very frequently asked question. Is it okay to do the blastocyst collapse with laser? Many clinics do it. They feel it's easy to get the blastocyst collapse with laser, but we do not recommend it because the blastocyst will get too stressed. It's too stressing for the oocytes because you are literally burning the blastocyst. And with this much stress, the blastocyst is going to collapse very tight and the expansion is going to take longer. So we recommend the pre-collapse that I showed you before with DS and washing solution because it's better to expose the blastocyst to the dehydration with the similar solution to avoid extra stress. This is a way to smoothly through the same procedure, just one extra step smoothly to dehydration. If the blastocyst takes long to collapse, it's safe to leave it there for a few minutes since the DS and the washing solution do not contain any cryoprotectants. So if it's very fully expanded or hatched blastocyst, it may take long time. So it's okay to leave it there until it slowly collapses. Remember, we're always observing our cells. Observe the oocytes, observe the embryos to see how they react. Just give them their own time, okay? Can blastocysts be frozen after biopsy? Yes. Actually, this is a common practice. I've seen clinics that they immediately after biopsy, one embryologist goes for the tubing for the biopsy and the other embryologist goes to vitrify immediately. It depends on the clinic. Another clinics like to wait 30, 45 minutes until the blastocysts are re-expanding again and then vitrify. So both of them are okay. But in the case you go to vitrify immediately after the biopsy, it might be a little difficult to determine the volume of the original embryo because remember we need to wait to the 100% recovery as it was before. So if we cannot see how it was originally, we better wait the 15 minutes maximum time for recovery in ES. So every time we cannot confirm the full re-expansion, either because it is too big cell or too compact to collapse that it's not re-expanding, or we are not sure if it's 90% or 100% re-expansion. Every time we cannot confirm, we will wait the maximum time in ES, which is 15 minutes for oocytes and blastocysts, and 12 minutes for cleaved embryos, or we saw the compact morula. Why is there a difference in the shape of oocyte embryos when they shrink in ES? We all have seen how sometimes the oocytes shrink very pretty, very round, and other oocytes that do not shrink very regularly. So these oocytes are from the same patients, but why are they shrinking differently? This is because of the membrane permeability. So this is how the water flows in and out of the membrane. So we know that the water flows in and out of the membrane by diffusion through the phospholipid bilayer, the diffusion, and also by some kinds of pores of pores in the membrane, especially the ones called aquaporins. So there are many aquaporins distributed throughout the surface of the cell membrane. So if these aquaporins are distributed uniformly, the water will come out uniformly, and then they will shrink very round. The water will come out at the same rate from all the surface of the oocyte. However, if they are not distributed uniformly, they have more aquaporins here, and here they have very few. So here the water comes out slower, and here the water comes out faster. And this one has a very irregular distribution of aquaporins. So this is because of membrane permeability. And remember, also aquaporins are responsible of cell division. So this can give us an idea. So the way that the oocytes shrink, the way that the water comes out of the cell can give us an idea of the quality of embryo that we will have after fertilization. Attention, only visually quality of embryo. We do not know the genetic quality. Visually, This oocyte can have better quality of embryos because the aquaporins are distributed uniformly, and this will give a uniform division, okay? And this one may give us fragmentation or irregular division. So the way the oocytes shrink in ES can give us an idea of the future of the cell, but only visually. Okay. Is there a time limit for the VS1 and VS2 steps? No, no time limits. You do not need to worry about time in any step. So remember, we only have to observe the embryo and the oocyte and how it interacts with its own environment. Okay, so in VS1 step, we need to observe how the oocyte floats, and then we put it back in the bottom and stop floating. It's very important to confirm, stop floating. If we put the oocyte in the bottom and it goes again to the surface, it means that in the oocyte there's still some ES. So we need to put it back in the bottom and wait until it stops floating, okay? So VS1 step, please confirm, stop floating. VS2 step, please confirm it's collapsed. So as long as we confirm that it stops floating and it's collapsed, don't worry about the time. Sometimes the oocytes stop floating fast. Some other oocytes, especially embryos of expanded blastocysts, they take a little bit longer. Maybe you have to put them down 1 or 2 times here. It's more important to confirm this than look at the time. So forget of the time when you are in VS. It's more important that we put VS and take out all the ES of the oocyte. It's more important that to look at the time. So forget of the timer, put away the timer, don't worry, okay? So what happens if we don't fully remove the ES in the VS steps? So I'm gonna show you a small video. This is played with 3 droplets. This droplet is only ES, our first step. This is only VS. This is what we want to achieve, only VS. And this is a mix of ES and VS, and you will see what happens when the VS is not clean. So it's going to be immersed in liquid nitrogen. We put our 3 droplets in the liquid nitrogen. And remember, when we start to see white, it means ice crystal formation. Okay, so ES only, all crystals. ES and VS, also crystals. So pay attention, VS only, no crystals. So it is very, very important to confirm that there's no more ES in our oocyte when we are washing in VS. So it's very important to confirm, stop floating and shrinking. We need to confirm this too. If the oocyte floats to the surface, it means there's still ES, okay? And if there's still ES, if the oocyte goes to the surface, it will have ice crystal formation. Okay, can I use less than 300 microliters of solutions? This is very common practice, unfortunately, because sometimes the physicians or administration in the clinics tells us, the laboratory, to cut out expenses. We need to save money. And it's easy to say, oh, let's reduce the volume of vitrification because 300 microliters is a lot. But the Cryotec protocol is designed with this volume for many reasons. We need to keep the 300 microliters of solutions for many reasons. In ES, we need to keep the 300 microliters. So when we put the oocyte in the surface and it sinks, the culture medium will stay in the surface. Okay. Also, all this way down will help the oocyte rinse, and it will give the oocyte time and space to slowly shrink. Remember, we need to make the oocytes and the embryos very comfortable. So give them their own space and leave the previous medium at the surface. In VS, we need VS because we have washings in 2 different depths, because we want to avoid osmotic shock. And also, very important, what I was telling before, we need this to observe the floating. If we have less volume, we will not be able to see the floating, to confirm the floating, and we will not be able to confirm the real exchange of ES into VS. Maybe if we don't see this, maybe the oocyte will be in somewhere and there's still some ES inside, and this will make the risk of ice crystal formation. So we need all this medium to observe the floating. And also the ES stays in the surface because it's different density, okay? So we need the ES or the previous medium, the culture medium or the ES here, and our oocyte in the clean area of the well. In DS and washing solution 1, we need all the volume because we need all this to perform a correct dilution for the appropriate osmolarity change. Imagine we bring 3 millimeter solution of the previous, but we only have this volume. The dilution will not be enough, and the recovery of the water will not be enough. And also, the reactions are going to take longer. So please keep the 300 microliters of volume of each solution. Please do not reduce the volume. If the clinic is asking us to reduce costs, better tell them, why not you increase a little bit the volume for the patient? We are sure the patient is will prefer to pay a little bit more to ensure the survival of the oocytes and their embryos. If we reduce a little bit, it's gonna be a little few dollars of saving, but we can risk the patient's cycle, the whole cycle, and then it will be more expensive for them to pay a full cycle. So please do not reduce the costs. Please explain to your clinics that it's better to not save a few money here for the good sake of the patient. Okay, so loading. What's the appropriate size of the droplet when we load? The appropriate size is from 300 to 700 micrometers in diameter from here. So this, the area of the sheet, this distance is 1,400 micrometers. So we can go from 1/3 to half the size of the Cryotec maximum, okay? You can calculate visually how big you can make the droplets, and also don't forget to calculate the droplets also have to be tall, not short. This is a very short droplet, and this can damage the oocytes or embryos. So please make tall droplets and do not minimize the volume, okay? So from 300 to 700 micrometers in diameter, the drop. What is the suitable inner diameter of the pipette for vitrification? So we know we use different diameters for normal handling, for denuding, for whatever. So for vitrification, for oocytes and cleaved embryos, from 150 to 170. Some clinics use 145 micrometers. It's okay, still okay, considering that the diameter of the oocyte is around 130 micrometers. We need to give the oocyte a very comfortable space to go in and out. The denuding, you know, it's very tight. And since we're exposing the oocytes to some chemicals and going through reactions, if we use a very small pipette, we can break the oocyte. And for normal handling, we usually give some space and a lot of medium can come in. So let's make an pipette that the oocyte can go in and out smoothly, but not with very much space, so we don't bring very much of the previous solution. So please use this size for oocytes and cleaved embryos, and for blastocysts, depending on the size of the expansion, from 200 micrometers from early blastocysts to 250 micrometers, because remember the maximum diameter we want to vitrify is 220. So we're going to give a little bit more space to the blastocysts to go in and out smoothly and comfortable through the pipe. Okay. So this is another question. When we vitrify after warming, some of the blastomeres of a cleaved stage embryo died. Can I consider it to be alive or not? So it depends on the number of cells that survive. If we have a 4 to 5 cell embryo, and when we warm it, we have 2 or more cells alive, we can confirm its survival, because remember that at these stages, the cells of the embryos are still pluripotential, totipotential cells. So if 2 died, the other 2 can compensate the loss and can create the embryo, the full embryo, full healthy embryo without any problem. So for 8 cell embryos, from 3 and more cells alive, it's considered alive. And from a blastocyst, from the 30% of the cells and more is considered alive. From this number of cells, the embryo is capable itself to recover itself and compensate the lost cells so it can create a healthy embryo. So don't worry if you lose a few cells after vitrification, you will have your embryo still have chance for implantation. But if you perform the good protocol, this will not happen unless the embryo is not a good quality embryo. But it's no problem if you lose a few cells. Another technical question, what should I do with the open reagent that was not used? So the vitrification kit is used, you will buy it for 3 vitrifications, and maybe you will use for 1 patient or 2 patients, and you still have some remaining medium. So if you close it tightly and you seal it, you can store it in the refrigerator and use it for within 2 weeks. It's also important that when you use it, when you open it, we usually do it in the how you say, the cabin, the flow cabin. It's supposed to be a sterile area. If this is a sterile area and you open it there and you close tightly there and seal it and then go to the refrigerator, it's good to go for 2 weeks, the same as any other culture solutions. So don't worry. But if in between these 2 weeks you see a different color of the solutions, or you see them cloudy with a little bit dust, please discard them. It means that they are contaminated, okay? So 2 weeks, you can still use your solutions after opening them. So last slide, Cryotec and other brands. First, can Cryotec products be used to thaw oocytes or embryos that were frozen using other products? This is common, especially when we are a clinic that has many years and they started to vitrify with one brand and now they changed to Cryotec, or from clinics that warm patients or donors from other places. So usually they vitrify, they can vitrify with some solutions of other brands, but we are using Cryotec. So can we use Cryotec to warm those oocytes or embryos that were not vitrified by Cryotec? Yes, definitely we can use those, but we cannot guarantee the 100% survival because first of all, solutions are not the same quality and the protocol also might be different. So the, how you say, the purpose of vitrification, the principles of vitrification is the same in all the brands. However, the composition of the solutions might be different, and this will maybe cause a decrease in the survival. Another, can reagents of other company be used in combination with Cryotec plastic? Yes, we can use the solutions of other brands, but we can also not guarantee the results of the equivalent to the ones with Cryotec. So even if we use the same plastic products and the same protocol, this is not all that gives success to Cryotec. Another thing that gives success to Cryotec is the solutions. If you don't use the same solutions, we cannot guarantee the best survival. Okay, so you can use other medium, yes, you can use the same plates, you can use the same straw, but if you don't use the same medium, you will not have the best, you might not have the best results. And finally, can oocytes and embryos be frozen that were frozen by closed method be thawed by Cryotec? This is also from clinics that have embryos frozen from many years ago. Yes, they can be thawed with Cryotec. However, because the process is also basically the same, all the vitrification and warming protocols you will know will consist first in dehydration, freezing, and rehydration. So the principle is the same. Procedure is basically the same, so that's why you can use the medium Cryotec products with other products. However, as always, we cannot guarantee the results the same as obtained with Cryotec products. First of all, because we don't know how were they frozen, and second of all, because the quality of the products is not the same. Okay, so this is all from my part. I see I already have 2 questions. I leave you my email here if you have further questions, so you can write me anytime. And right now in this seminar, if you have another questions, I will be happy to answer them.